Hi, this is just a quick video to explain something that I think catches students a lot when we're working with heat transfer, especially with temperatures. So this is a problem from another textbook, but it came up last semester where a student asked a question about why can I use degrees instead of Kelvin, and that back and forth question. So let's take a look at what's happening here. We're given a temperature profile that's quadratic. So again, we looked at this in class. A has the units of 200 degrees C, so that's a constant. And then B has the units of minus 200 degrees C per meter squared. And when you multiply it by x squared, the units will again be degrees. So that's what I have written down here. And if we understand now that as long as we specify the coordinate, the spatial coordinates in meters, the temperature will be given as degrees. So I can just rewrite this as with the degrees out on the right-hand side, right? So now and you notice I have this little subscript here, temperature in degrees C as a function of x. Now, if we wish, we're free to express this as Kelvin, but in this case, look, all we're doing is we're adding 273.15 degrees to the right-hand side of the equation. So this is in centigrade and this is in degrees. So you see here that when I plot these, the plots are exactly the same. The only thing that's happening here when you put it into Kelvin is you're shifting the curve up and down, but you haven't really changed anything. The scales, the temperature scales are different, but they still represent the exact same thing. Now, the answer or the question that was posed in class was, how can I do this? And when I take the derivative, what happens? Can I still just use degrees as opposed to Kelvin? All right, well, let's take a look at it. So if we are going to use the heat equation, and this one is with energy generation, what happens when I take the first derivative and what happens when I take the second derivative? Well, when both equations are differentiated, they produce the same results, right? But they have different units now, right? So the first one in degrees C was degrees centigrade per meter, and the second one is in Kelvin, so I end up with, if I keeping the units the same, it's negative 4,000 x Kelvin per meter. So now, which one do I use? Well, if you think about it, both of these expressions describe the slope of the temperature field at the specified location. And the units of the slope are degree per meter. And the degree for the Celsius range and the Kelvin range are the same. That's the same. So if you move up or down, in this case, if x was 1, then I would be moving down 4,000 degrees per meter. In this case, I would be moving down 4,000 degrees per meter. I'd be moving down 4,000 Celsius degrees or 4,000 Kelvin degrees, but the meaning is the same. The slope is so many degrees per meter. And the second derivative is basically the same situation. So again, we would get a situation here with degrees centigrade per meter squared, but the only thing that we're talking about here is the concavity of the function, right? So that's the difference between the two expressions. Again, they're only shifted by a value of 273. So it should be apparent that these two results describe the same situation. So again, you can either be, when you're dealing with a temperature profile such as this, you can use it either as degrees centigrade or degree Kelvin, doesn't matter, but you have to remember that where you do that, you don't add 273 to each one of these individual constants. It's just adding 273 degrees to the equation. Just you're doing that shift up and down. So hopefully this makes sense. I'll post this to Blackboard and hopefully you can read through this, and hopefully again it will make some sense to you. All right.